Good morning. Welcome to the Cities Charging Ahead webinar number 2. And really excited to have the Cities Charging Ahead cities and other interested parties on the line for this webinar. As folks know, the Cities Charging Ahead effort is led by the Great Plains Institute and CERT, the Clean Energy Resource Team. So for today's talk, do a welcome, which I just did, and then we'll talk about some of the basics of charging, charging infrastructure and practical decisions, smart charging, solar energy innovation network, and some resources. And so first, before I get started, I wanted to share a little bit about how this project is funded. The funding for the project that we're doing with Cities Charging Ahead is being funded with support from the Energy Foundation and the Carolyn Foundation. In addition, Xcel Energy has recently joined and is partnering with Cities Charging Ahead by providing support and resources in line with the company's long-term clean energy plan to electrify transportation. So we're happy to have all of those funding sources to support the efforts that we're doing right now. So first up, we have Fran Crotty from the Minnesota Pollution Control Agency, who will be talking about the basics of charging. Fran.
Okay, thank you, Diana. So there are 3 types of charging stations, and they're distinguished by the level of power that they have, which relates to how long it takes for them to provide a charge. As you increase the speed of the charging, you also increase the cost. So that's why you don't necessarily want to go put a fast charging station in at every location. And we're going to be talking about the different types of stations and uses, and so that when you are thinking and planning about where you want to put your charging station, you can think about, well, do I want to make this charging available to my employees, to the public, or for my fleets, or for all 3, and that will determine how much you're going to want to spend and invest in your charging. Early on, the Society of Automotive Engineers, their international group, decided on a universal standard that is used around the world. It's used globally. It's called J1772, and it is this connector, so that every electric vehicle that is charging at the level 2 or level 1 level can plug in using the same connector. So that was a huge accomplishment that they set this charging standard up early on. The University of Minnesota has installed some level 1 charging stations, and these stations will give you about 6 miles of charge in an hour. So when their employees plug in and they're parked for the day, over the 8-hour time period, they can get about 48 miles of charge. And they may have driven 20 miles to get to the university for work, so they can recover their charge readily over the course of the day. So installing a level 1 charging stations can make a lot of sense for employee use. They're inexpensive to install. You can purchase them over the internet and just have an electrician, any electrician, install them. Here's an example of a level 2 charging station that is the 240 volt level. It has a dual charging, which means there's 2 connectors or cables coming out of the single station so that 2 cars can charge at once. This one is in the Lebanon Hills Park. It was originally installed for fleet use by Dakota County, and I believe they have opened it up to the public for public use as well. But so you can mix and match the uses for these stations, and you know, the use case in this example evolved to where they were expanded who they were going to allow to use it. And typically we say you can get a 100-mile charge in about 4 hours with this station. So if someone is visiting the park and they're going to be walking around on the trails for 3 or 4 hours, it works. It's a really good fit. It really matches the use with the type of station. Here's an example of the city of Eden Prairie where they've got a wall-mounted level 2 for their fleet use. And then we have the direct current fast charging, and these are the stations where you can, we say you can achieve a full charge in 5 minutes to 20 to 30 minutes. The 50 kilowatt hour station that you see here will give you a full charge in about 20 minutes to a half an hour. These stations are evolving and becoming faster and faster on up to, you have 350 kilowatt hour stations, big power stations that are going to allow you to charge your car up in about the same time it takes for a gas car to fill a tank of gas. So 10 minutes or a little bit less than 10 minutes. These are the two charging connectors that you need to be aware of with fast charging stations. All of our fast charging stations, perhaps with the exception of a couple that are automotive dealers in the state, have both of these connectors. And the reason is that in this case, there was no one universal standard decided on by the world. So your Asian models of cars, like the Leaf and the Kia Soul EV, they're going to use this CHAdeMO standard. That doesn't translate readily. Just take it that it's an acronym called CHAdeMO that's for the Asian vehicles. Combined charging system is, or CCS, you'll hear called CCS, is used by the US and European models, including the BMW and the Chevy Spark, those type of cars. So this chart compares the costs. And again, we put fast charging stations in everywhere if they were really cheap, but they're not. They're an investment. And so you want to really match your use case with the type of charging station so that you can keep your costs in line with what you had planned. And also, if you are going to go with a less expensive station, you can put in more level 1 stations than you can level 2s. So if you want to put a bank of charging stations in for your employees, a level 1 is a really good way to go, rather than the level 2. If you have a lot of visitors to your facility, your city hall, or other public works facility, something like that, you might want to put in level 2s, because these would allow a visitor to your city hall to go to a 1 or 2 hour meeting and achieve a full charge, and then they can drive home. So, and then when we look at the fast chargers, a lot of these are located currently at some of the automotive dealerships have them if they sell electric vehicles. A lot of our Goodwill stores are hosting them, the 50 kWs. And we hope in the future to build out charging corridors along highways so that people can travel long distances. In my case, for example, I lived in a northern suburb. I would travel down the Savage to see my daughter. I would need to charge up by the time I got there because I'm going, clear across the city. And so I would pull into the Savage Goodwill, I'd charge up, and then I would, for 20 minutes to half hour, and then I'd go home. So it allowed me to travel a long distance. A couple of things to be aware of, and you're going to hear more about this in the following presentations, but I want to mention that it's extremely important to pair electric vehicle charging with renewable energy. When you have zero emissions from an electric vehicle tailpipe, but you're pairing that with no emissions from the generation of the electricity used to power the vehicle, because you're using solar or wind generated renewable sources of electricity, it results in zero emission vehicles, or ZEVs. And this can be readily done in Minnesota and inexpensively done. You can sign up for wind programs really inexpensively through your utility or community solar. In this particular charging station, this station is signed up through an Xcel Energy wind program, and so we placed a decal on it to advertise that it is being powered by renewable energy. So that's one of the advantages, is that you can talk about this in your sustainability plans or your other PR that you're doing around sustainability, that you have your charging stations powered by renewable sources of energy. And the other thing that we're going to hear more about too is smart or intelligent charging, but I'll let the following presentations go into that in more detail. Once your station is installed, you're going to make sure you have adequate signage. Stencil on the pavement in the parking space is really good for letting people know this is for EVs only. Otherwise, you're going to get gas cars pulling in there and charging. In addition, you want some signage. These two examples of signage are Federal Highway Administration approved under MUTCAD. Some of you are familiar with that standard signage. You may see a little variation on these, electric vehicle charging only. Some people put underneath there, or only when the vehicle's charging, something like that. But these are the two sort of standard signs that you would want on actual signposts by your station. You're going to want bollards up to protect the station so that people don't run into it. This is one of the University of Minnesota stations where they've got a bollard to protect it. And then something else to also consider is you should take a look at the American Disabilities Act booklet for compliance for charging station installations as well. And that's found that the booklet has this number. Once you put your station in, we want to know about it because we keep two maps up to date. One of them is the plugshare.com map. This is an international map used around the globe, and we do keep it up to date. It has these really nice balloons where you can click on them and you can actually see photos of it. It's got direction. It'll lead you right into the station if you need that assistance. So you pull it up on your phone. It's just a really great app. I use it all the time to find stations when I need them. And then the U.S. Department of Energy Alternative Fuel site also maintains and tracks where the charging stations are. So we need to let them know when you put a station in. And this is for all of the stations, level 1, level 2, DC fast, any of them. This is a slide I showed in the first presentation that we had, and I wanted to show it again. The state of Minnesota does have a contract for charging station equipment that you can purchase off of. This relieves you of the burden of having to go out for bids. You can go have your purchaser pull up this contract, and it lists all of the charging stations that are readily available to you. If you see charging stations that are not on this list, however, you can still purchase them through competitive contracts. Our purchasing person, our green purchasing staff at MPCA works with a number of joint purchasing agreements with other states. So there's a lot of brands of charging stations that are available and open that have already been bid out if you want to use this assistance. And of course, you can always go outside and do your own purchasing as well. But we just like to provide this as a service to help the local units of government with your purchases. My contact name is up here, and I am going to be retiring in a couple of weeks, so I also wanted to include Rebecca Place, who is my replacement. I'm really excited about her coming on board. She's going to be really terrific, and so feel free to contact her. I've got her email and phone number, and going forward, and she'll be able to help you out.
Thank you so much, Fran. So we'll pause for just a couple minutes here to see if there are questions from folks on the webinar. If not, I've got like 3, but I'll probably only ask 1. So hopefully one of you will have some of the questions that I have.
And again, as a reminder, for questions, you can use the Q&A feature on the webinar.
I saw Amber raised her hand.
All right, Amber, it looks like you have a question, so we have you unmuted.
Amber, are you there?
Oh.
Hold on.
Didn't have a microphone.
Oh, you don't have a microphone. Okay, so you wrote the question. So does the DOE or Department of Energy, for those folks that don't know, include home chargers or public only?
It would be public only, right?
That was one of my questions. And same with PlugShare? Is that just ones that are available? Because if it's your home one and you're not letting people use it, what's the point of putting it on the map, right?
Right, it'd be ones, yeah, that's correct. It'd be ones that are available. They do allow home charging to be posted on it, but quite frankly, I'm not, with the build out of the public infrastructure, I'm not sure if people do that anymore.
But you could, if one wanted to.
You could if you wanted
They
to,
could.
yes.
All right, looks like we've got John Howard with a question. John asks, could you please include cost and charging information on the 25 kilowatt DC fast charger? Thank you.
That's a great question, John, because there are sites that want a fast charger, but they don't want to do the heavy investment of the 50 kW. So there are some sites that do a 25 kW DC fast charger, and that's a nice option. Of course, your charging rate is, you know, going to be twice as long. Let me put it that way. So again, you have to, you know, decide what your use case is and what, you know, what's a good fit for you. I don't readily have the cost information on that. I don't know, Jim, there's someone else here that may.
Yeah, the 25 kilowatt fast chargers, you know, the installation will vary across the site, but the equipment itself is on the order of 15,000, you know, for a 25 kilowatt fast charger. And it's tough to quote the install based on site-specific conditions, but I think they, in the end, come in, you know, I would say about half price, if not a little bit less, than a 50 kilowatt DC fast charger installation.
So are you saying it's 15,000 for just the equipment, not including the install?
That's correct.
Okay, just to be clear, and the install about half of the price of a 50 kW install. All right, good question. Maybe we'll take one more question, or if not, I have a question. So my question is really elementary. On the slide where you had the basic charging, the level 1, level 2, et cetera, are AC, and then it moves to DC for the fast chargers. Why is that? What's the difference?
Oh, that's a good question.
Thank you.
Well, it's just the source of electricity that's used. I'm actually not totally certain of the history. Jim, I'll let you take that over if you know.
Yeah, so Brandon, you're right that depending on the source of electricity, so for those level 1 and 2 chargers, oftentimes you'll have a, you know, level 1 chargers, you have got a lot of them in your house, right? They're just a standard 110 outlet, but a level 2 charger is kind of like a dryer, you know, electric dryer out of the 240. So those are more readily available, AC, you know, power in a residential sense and in a commercial sense too. So as a consequence, that power, when you plug in that J1772, that one for level 1 and 2 in your car actually has to do the conversion from AC to DC. So these cars will be built with that capability to do that because batteries are receive direct current. Contrary, a DC fast charger works on DC power, and that will charge, kind of go into the battery directly without being converted, you know, by that car from AC to DC. So, but the big point would be level 1 and 2s, that power is usually available via kind of standard outlets, whereas DC stuff gets bigger, and you'll have things such as transformers to drop AC distribution lines and convert it into DC so that it can directly charge your car without another conversion.
Awesome, that is really helpful to understand, because it's just about the alphabet soup for some of us. So I think that's it. Unless there's other questions, I think we'll move on to the next presentation. So the next presentation, our friends from Fleet for the Future. So Philip Krajcik And Kelly Blinn will be talking about electric vehicle charging infrastructure and some of the practical decisions. I know that when we talk to the cities and cities charging ahead, there's a lot of decisions you need to make, and we have a lot of questions around that. So Philip and Kelly will enlighten us. Philip, Kelly?
Hi, can you guys hear me?
Yep,
And is my screen coming up?
it is. We can see the PowerPoint now.
Great, yeah. So my name is Philip Krajcik. I'm with the Cadmus Group, which is a sustainability consulting company that works on renewable energy, clean technology, clean vehicles, energy efficiency, and similar projects with a focus on delivering social good. I'm also with the Fleets for the Future project, which I'll talk about as well. I'm trying to cram a lot into 15 minutes, so bear with me if the information comes at you a bit fast, but I'll just kick it off right here. So first, I wanted to step back and create a little bit of a broader framework for you, thinking through the context of EV charging within the broader suite of tools that are available to develop your EV market. And it's really important to note that we're just talking about one small component when you look at all the different things you could do, such as your fleet procurements of vehicles themselves, encouraging more consumer demand, awareness and education, engaging the industry, all sorts of things like that. Similarly, I'm going to focus my comments today on specifically EV ready and direct investments in EV charging, whereas there are a whole bunch of other strategies around infrastructure development. And I'm also going to focus my comments with the assumption that we're talking about level 1 and level 2 charging for the most part, because that's where we've heard the most interest from municipal stakeholders. And then finally, I'm going to assume that we're mainly interested in the EV sedan market based on what GPI told me about you guys as attendees. But I've asked my colleague Kelly Blinn, who's an expert in heavy-duty electrification, to join us as well for the Q&A in case you do want to talk about applications such as transit or school buses. So to kick things off, starting with EV-ready ordinances, these are actions that make it easier and less expensive to later install any type of EV charging at a development. And the obvious benefit of this is that it can catalyze the development of EV charging and reduce the need for public sector entities to buy the equipment themselves. But the sort of limitation here is that it's inherently really just focused on a small subset of the building stock, because you're only looking at new construction over certain size thresholds. These can be mandates, sometimes they're development incentives, and they typically involve things like selecting panels that can allow higher amperage, installing underground conduits that go from the panel to the EV parking space, even if you don't have a charging station there yet, or even including a complete EV circuit that has wiring all the way there. But they sort of stop at the EV charging station itself. And the assumption is that if you've made a mandate to have parking spaces EV ready, developers will naturally just want to go the final step and actually include the station itself, so that you've got the option to charge. There's a number of leaders in the country you can read about later, Vermont and California, and a number of cities from some of the normal ones you'd expect in California to Denver and New York City and beyond. The amount of cost savings here is quite variable because there's a lot of different definitions for what would be an EV-ready action. Typically you can see cost savings of 25% to 85% as a study that Oakland commissioned found. And it's really going to depend a lot on what sites you're looking at and what action you're talking about. So it's also important to contextualize municipal EV charging investments, moving on to the sort of direct investment side of things, within the landscape of additional investments that are being made by other entities. You should really ask yourself before you get started on this, whether you see your role as being a catalyst, sort of a primary actor that's jumpstarting the market, or as an entity maybe more likely that's filling critical gaps in the infrastructure. And then finally, another way to think about it is you could conceive of yourselves as enablers that set the right policy environment for the EV market to thrive. there's a growing body of research that we won't really discuss about the importance of the density of an EV charging network in the decision to own an EV. So we're going to sort of operate on the assumption that a more robust network does have significant benefits to municipalities. And the other thing to keep in mind is I've listed out a number of contextual factors such as existing EV charging stations. You see on the right-hand side a snapshot from the AFDC that Fran mentioned in a previous presentation, where there's charging stations already available in Rochester to the general public. And then there's any number of programs and plans that you should be keeping an eye on to make sure that you're complementing them as best you can. The utility programs, Minnesota is one of a relatively small number of states that have approved pilots to rate-based EV charging investments by utilities. So I think Caitlin's going to be talking a little bit more about Excel and its programs. And then obviously you've all heard about the VW settlements with their investments and private sector workplace investments. So there's a lot going on, and it's important to note that the municipality doesn't have to be the only one who's contributing to this. So to jump into some of these practical questions, first, how should you prioritize your investments? Looking at sites that are under municipal control, you're going to want to ask a number of questions that help you determine whether sites are strategic. First, you'll want to ask if they can support high utilization, and you might ask as a subset of this, are there other chargers nearby? Are they typically used a lot? And what times of day are drivers likely to use the station? Are they stopping by on the way home from work? Are they stopping at the municipal offices to have a meeting, as Fran mentioned? Or is it a really short window, or is it a longer window of time that they may have available? And then, so the question there is dwell time and whether they have a long enough time to warrant even plugging in. There's a lot of, if you're assuming that you're catching people on their commutes, they're probably not going to stop long. So finally, you'll want to ask yourself essentially, what evidence is available to inform your hypotheses about all these questions? And you'll also want to look at potential fatal flaws. And in that category, I would throw things like really above average trenching and installation costs, having electrical service that's not sufficient to host enough vehicles for the use case you need, and incurring more costs than you're willing to incur for the investment. So those sorts of things should be evaluated. And then, of course, the context of what charging stations are around in your area. The bottom line here, I think, is that you could do a really sophisticated analysis like GIS work to optimize your network based on, say, demographics and income and flows of electric vehicles and distance from EV routes that you're modeling, traditional transportation modeler work. But honestly, it's likely to come down to common sense and local knowledge more than anything else as you try to cite the small number of stations that you're looking to cite. And that, I think, is one of the major differences between DC fast charge and level 2. So if you ask those questions that I laid out on this slide, I think you'll probably be getting yourself 90% of the way to finding the best places. Next question I wanted to address is, where should chargers be located on site once you've already identified the sites? Again, there's no real right answer here, but there's a couple areas that I think are particularly compelling. One would be thinking about near the entrance to the facility, and then the other way to think about it is what's nearest to electrical service. And these may not be proximal to each other. You may be lucky that they are, but you're going to want to typically choose sites near the entrance if you want to prioritize visibility, whereas if you want to prioritize least cost installation, you're going to want to look at the electrical service. And another thing to think about is what is the landscaping or hardscaping situation at your facility. The more hardscaping you have to trench through, the more your costs are going to rack up. Whereas if you're going through landscape surface and laying conduits, not going to be nearly as expensive. Other major decisions you'll want to think about is if you've got indoor parking available, is that where you want to put the charging, or do you want to have it outdoors? And the considerations here are connectivity, depending on if you're using cell networks or Wi-Fi or Ethernet. You just want to make sure that you have sufficient connectivity to do the all the network services associated with billing and reporting the status of the station to EV users that may want to stop. And then another interesting consideration around indoor charging is that in a cold and hot climate like Minnesota, having the vehicles indoors could have a significant range benefit because auxiliary loads like the heating and air conditioning system in the car are quite significant. And so if they're only stopping for a little while, the marginal benefit of keeping the car from getting really cold will actually be pretty significant in the efficacy of their charge and the ability to have more range. And then I touched on a bunch of these other considerations as I talked, but wayfinding and signage, as Fran mentioned, are important. Ease of enforcement, security, copper is very valuable, so you want to make sure that if you're worried about vandalism or theft, you put it in a place where it's secure, cable management, and similar considerations. So another question is whether you should charge for people's access to the charging station. And here I just want to back up a little bit to say that a key challenge is that while the transition to EVs has significant benefits to society, the investment in infrastructure doesn't often pencil out for the site owner. And I've put on this slide an example from a project we did for the Washington State Legislature, where you can see a massive upfront investment that's recouped very, very slowly over about 10 years. And typically the reason that these don't pencil out very well is there's a low utilization of stations, particularly in the early years. There also can be a low willingness to pay when the alternative is to charge for free at another station or where there's low cost home charging available. And then, of course, the high time value of money associated with any upfront investment. So I say this all to say when you're evaluating whether or not to charge for charging, it's worth thinking about the fact that you're not likely to be breaking even if you're charging for charging, you're simply reducing the net cost. And of course, there are many reasons you'd want to do this, but it's just important to keep that in context. Another mitigating factor here is that in the context of the VW settlement, and perhaps someone else is going to talk in more detail about this, there's $176,000 available as part of the EV charging component for level 2, so 10% of the 1.7 million that's available, and that's in the next 2 years. So that will cover a significant amount of that upfront cost, as I sort of modified the slide to show, and then your payback period may look much better. The thing is that $176,000 won't necessarily go all that far across a large state, so it's not necessarily a total solution, but it definitely will help for the recipients of that grant funding. So then some questions you want to ask when evaluating this question are the level of financial risk that you find acceptable. What are the optics going to be of providing free charging both to EV owners and to non-EV owners? And really ask yourself, how much will the fact that the charging is free impact EV adoption and your overall goals around it? Will that element really help make sort of tip the balance for potential owners of EVs? Does free charging encourage people to be parked in a place longer than you want them to? Sometimes turnover is good in your parking spaces, particularly when you're thinking about retail locations. And then, are there ways to take equity into consideration when you're developing your charging schemes? On the right side of the slide, you'll see a figure that I pulled from our report for Washington State. And it just shows the sort of gamut of costs and revenues that you can expect from EV charging investments. And an important thing to note here is that there are other beneficiaries beyond the station owner and the EV driver. And so you want to think about what benefits utilities are getting from this, the OEMs, dealerships, local businesses, and even advertisers. And that's important because if you're trying to justify the investment, as you see, trying to improve the financial picture can include the possibility of getting contributions from other beneficiaries and seeing if there are other entities that might want to chip in. Other sorts of ways that you might want to improve the financial picture include right sizing. The example that I showed before was an example with 5 parking spaces, but perhaps you only need 1 or 2 cables at a site in the beginning. And as we talked about with the EV ready discussion, more can be added later, particularly if you've done sufficient planning around it. Another way to improve the financial picture is to look at different ways to ownership and operation models. So companies have recently been approaching cities with proposals to provide EV charging stations at no cost, basically in exchange for the ability to take the revenue from using the city-owned parking space for their own for their charging station. And then another alternative model is something that we've seen in Berkeley and Philadelphia, where they've allowed EV owners to convert curb parking in front of their residents to EV charging at their own cost. And these programs had different sort of stipulations associated with that. And I don't have the details off the top of my head, but I can get back to you if you have questions and want to learn more about either of those programs. So the last question that I was asked to address is how can you future-proof your investment in EV charging infrastructure? And this can mean a lot of things. Most commonly, people are concerned with making sure they have planned around how much current they're prepared to deliver. In case, for instance, there's a larger number of vehicles that want to simultaneously charge. You also want to be thinking about the fact that specifications can change and vehicle capabilities. Earlier generations of EVs were capped at 3.3 kW for onboard charging on level 2. Now most of them are at 6.6 and some are slightly different standards. But both the number of vehicles and the amount of charge they're planning to take at any given time will impact the amount of current you need to be able to provide. And the considerations are obviously the sizing of the electrical panel, sizing the conduit, so you could run additional heavy gauge wires through it, and whether you run the trench into additional spaces. And that's particularly of interest if you already have a contractor doing trenching. The marginal cost may not be so great to just have that option for the future. And some of these things will have very small additional incremental costs, and others will be a bit more significant. So you're going to want to really question your assumptions about how demand is going to grow, and is it going to be soon enough to make various future-proofing efforts worthwhile. Other sorts of future-proofing considerations you might want to address include looking for EV charging that has smart power management, which could enable demand response. Vehicle to grid is obviously further in the future, but could be an interesting thing that smart chargers could enable. And then emerging business models are interesting to consider, such as mobile charging, where the company could actually move a battery between, roll a cart that has batteries on it between vehicles, reservable charging stations, and matching station owners with EV drivers. There's a whole bunch of startups that are doing really interesting things. So with that, I want to just very quickly tell you about this Fleets for the Future project that Diana alluded to, because there's specific opportunities to procure EV charging at a low cost through the project. So to start out, Fleets for the Future is a Department of Energy project, and we use cooperative procurement techniques to develop contracts for both charging and for EVs themselves. And it's a national project, but there's opportunities available in Minnesota. Two different entities have the main contracts here. There are procurement partners. One is called NJPA, based in northern Minnesota, just changed its name to Sourcewell, and the other is the Commonwealth of Massachusetts, has nationally piggybackable contracts that you could take advantage of. And I believe you're all municipalities or other government entities, so you're eligible to purchase off these. And the contract that we have, unlike most state contracts, are actually full catalog contracts. And this means that if a vendor that is awarded a contract has any sort of solution, they're able to give you a price for it through the contract, and you can purchase it without going out to a competitive bid. So the scope here includes level 1, level 2, and DC fast charge, maintenance, repair, parts and supplies. On the installation side, they'll do everything from the assessment and the preparation to the installation. And then finally, on network services, they can provide charge monitoring, reporting services, billing services, and various software and technology solutions. So the NJPA contracts, there's 5 vendors. I won't get into the details, but as I said, they're full catalog and they span that whole gamut of services. And then MAPC has an additional 6 vendors that don't actually overlap very much with NJPA's contract. So you have really rich set of options available. And to add to that, the Minnesota state contract that Fran mentioned, there's a lot that you can leverage without having to go through a procurement process. Just to give you a quick sense of the benefits of going off of a cooperative purchasing contract, I've put the hardware discounts in a chart here for each of the 5 vendors on NJPA. And typically the level 2 stations are available for about 15 to 30% below MSRP, and the DC fast charge are available for about 5 to 15% off. And so this is particularly useful for those of you who might be from smaller municipalities, because you might just be looking for 1 or 2 stations, and most of the time when you go directly through an RFP, you'll need a significant volume to get good pricing. But in this case, the cooperative contract, whether it's NJPA, Massachusetts, Minnesota, or the other state contracts that Fran alluded to, they all give you a really great opportunity to get that pricing and sort of alleviate some of those upfront cost barriers. So with that, I don't know if we still have time for questions, but that's all I wanted to address.
Thank you, Philip. I think if anyone raised their hand and has a question, oh, somebody already raised their hand. It looks like it was, sorry, we're just trying to find the question. In the meantime, so you give examples of co-ownership, and that was interesting, companies wanting to talk to the city about putting in a charger, and then you said that they would use the city land for free to put the charger in there. My understanding of talking to cities about this is that if they're going to let one vendor, one company use their land, they would probably have to go up for bid. They can't just do that with a company. And then secondly, on co-ownership, I'm curious if there's been, if you've seen anything, an example of city, a business, and or a business association that might find a value to putting a charger in on a main street location or in a business district or something where there's a, being creative about the ownership because of the high upfront cost.
Right, yeah, so I think on the first question, one of the sort of analogous situations, a number of cities have been looking to, say, A to B car share opportunities, and the same sort of situation applies where you can't really favor one vendor over others without having some sort of competitive bid process. And I know in Boston, they've done a project with A to B car share where they specifically ended up having multiple vendors because they wanted to level the playing field and not make it be a giveaway. And so maybe worth looking at some of the models where people have done that. Metropolitan Washington, D.C., the regional council there has been approached by a number of vendors, and they had that same question of trying to figure out how can we award a vendor an opportunity to provide charging, which at no cost, which would take a lot of pressure off the municipality to find the right sites and do the investment themselves. How can they do that in a way that's going to be compatible with their procurement bylaws and fairness? And I'm not sure I have the precise answers here, and maybe Kelly has some examples, but it is something that I think is surmountable and solvable. And It's just sort of going to be a case-by-case basis how each municipal government might want to work through it.
So we do have a question from John Howard. A question is, can Minnesota cities use the MAPC, the Massachusetts contract? It looks like you could.
Yeah, that's right. So they have set up their contracts in a way that they typically require people to sign up as users of the Combis system, and there's specific eligibility requirements, but they basically include any sort of municipality in the U.S. or even nonprofit. And what they do is, for Massachusetts entities that want to purchase off of those contracts, they require them to go out and ask for 3 quotes for the specific scope of work that they want to have performed for each of the vendors that's on contract, so that they still get that competitive pricing. But for municipalities outside of Massachusetts, there's no requirement to do that, though I think anyone would sort of recommend going out and trying to get a number of independent bids, particularly if it's as easy as just going to a number of vendors that already have the contract.
All right,
but short answer is yes, they're all available.
Thanks, Phil. And Kelly, hang on until the end if there's more questions, but we need to keep moving because we've got some other presentations. So next up, we have Jim Goodman from Zep Energy, who's going to talk about smart chargers.
Hi there, this is Jim, and here we go. What is smart charging? Well, let me get my notes. I gotta tell you what this is. So smart charging is really all things that aren't dumb charging, I suppose. And I'll get into that in a moment. I think dumb charging kind of has a little bit of a bite to it, but when something's dumb, I suppose it's in the eye of the beholder. I think for a lot of people that show up to a charger and they plug it in and it works, that's pretty smart. But there's another side of that I'm going to get into, kind of the back end of those people that are putting those chargers in, and those utilities that are sending power to those businesses or residences that eventually get those chargers. So just quick today, I'm going to introduce you to a company I work for, a smart charger. Why do I need one? Some examples, projects, and then a project that our company is kicking off called the Minnesota EV Baseline Project, centered around level 2 smart charging. Here we are. Zep Energy has 2 established business lines. Firstly, we started out in 2014, effectively building EV fast chargers, utilizing a model not dissimilar from Tesla. So Tesla wanted to have a network of chargers to support the sales of their vehicles, and Nissan did too. So a lot of our initial kind of funding to develop projects in the DC fast charging space came from Nissan. We've had the pleasure to work with a lot of counterparties with respect to these DC fast charging networks, but beyond that, I want to the majority of the rest of this presentation is going to be about our level 2 kind of smart charger product, and really level 2 in general, smart charging in general. Here's another little page on our fast charging development, but I'll get past that and just talk about our StepNet project, our product, and that's really just controlled and metered level 2 smart charging. So you can envision a charger that's installed. We are going to present the argument that charger should inherently log all of its use. It should be able to run load control programming on it, i.e., can you operate this charger at a 25% output, 50%, 75, 100? Also, built-in revenue grade metering within that charger. These are things that, frankly, are utility basic. When we think about smart charging, and I'll get into some benefits in a kind of a municipal sense, but for a utility, when you think about low growth opportunity, beneficial low growth, electric low growth opportunity for a utility, electric vehicle market is the biggest one they'll have seen in a long time. I think maybe in the 70s when residential side air conditioners kind of came into being, that was a very large low growth as people on the East Coast, that turn those on, and there you go, brown and blackouts. So we kind of want to avoid that when EVs, electric vehicle ownership, kind of goes up. We certainly expect that to happen. Moving on, demand reduction, kind of I'm talking about the features of smart charging, i.e. you can run multiple chargers off a single circuit. I'll get into a specific project that was done on this building that I'm in right now, a renewable dispatch project. We got another speaker on that later, so I'm going to keep it short. And then some connectivity that this charger would have, depending on the availability, to communicate back to, a place to kind of crunch that data. The smart nature of these chargers really leads upon their ability to be networked. And that's, the Wi-Fi, cellular, radio frequency mesh, Ethernet kind of connection to it. It also happens that our product's made here in Minnesota. What is a smart charger? Here we go, right from the top, and I guess I use this word dumb again, but smart chargers is a network station that has those previously mentioned features I spoke to. Dumb charger is not networked. So again, a dumb charger is a charger that exists that you plug it in and it just works 100% and you're pretty good to go. So again, eye of the beholder on that. I think for a user, an EV owner, not so bad. Kind of smart in that it works. But why would others care about that? And our argument here is we really feel that it's prudent for municipalities, cities, even utilities, any users and kind of protagonists of the development of level 2 chargers, they want to achieve usage information, and as a consequence, they can make better decision making. And beyond that, based upon the data you achieve, you can make decisions that puts your dollar to best use. So here's the contrary to why you want a smart charger is some hypotheticals. With a non-network, a dump station, how would you measure if your electric vehicle program is successful? I mean, other than just looking out there and looking at someone charging there, how can you do that in a passive, highly efficient sense? How would you measure how much it costs the organization by way of electricity sales if it's for instance, a non-metered installation? And how can you make those determinations on when and which facilities are appropriate to expand, or for that matter, dismantle? Here's part 2 of Smart Charger 101, and I guess it's a summary in a bit. In short, collecting data allows you to make well-informed decisions for your city or utility, and even if you don't collect usage fees on the stations, make sure you collect data on the usage to inform those decisions. So at Depth Energy, we do promote really free level 2 charging. I really appreciated the prior presenter, Philip, regarding what does that mean, to those people that don't have EVs, and are there some unintended consequences? And no kidding, just yesterday I ran into one of those unintended consequences of kind of the semblance of why would I subsidize their parking, right? For instance, it is a real concern. In the end, using smart chargers can save you money. Their really primary functionality, in addition to achieving just the data grab on what their use pattern is, but you can coordinate chargers across a network of chargers so that you do not hit demand charges. I'm just going to touch a moment on what demand charges are. I think most people would know that, but a lot of commercial rates for commercial entities, you have a certain demand charge on your peak usage, and that would be kind of in kilowatts, right? Not in kilowatt hours. So when you hit that peak, there can be penalties after that. And if you thought in a residential, I'm going to go to a residential analogy, average house runs at about, on average, 1.1 kilowatts is a house. And if you take a house and add a car that can charge at 7 kilowatts, you just kind of added 7 houses worth of demand to that node. That makes utilities kind of freak out, and as a consequence, they'll have to accommodate that somehow. And that problem of accommodation will definitely go on those ratepayers, I suppose, at utilities. So being proactive about charging your deployment of level 2 chargers in a kind of a smart fashion I think in the end does save you money primarily because you can shred those demand charges. Additionally, the technology is there, I think, via kind of miniaturization, whereby you can, in a very, I guess, in a very small, in a size sense, you can put revenue rate metering capabilities in a level 2 smart charger. So inherently, you buy one and it's in there already. And that means that when the utility comes out, if they're can concur that you do indeed have revenue rate metering inherent to your unit, they don't have to install a revenue rate meter to meter your level 2 chargers. In a residential sense, that's a big deal. You can really shred the cost. Heck, in a commercial sense, you just kind of shred the cost of not having to install this extra piece of infrastructure. Here's some projects that our firm have gone through. As I mentioned, this is this building, correct? Yep. We did a project with the Great Plains Institute on solar synchronization. So we really think about that, kind of shooting for the perfect on when a kilowatt hour of electrons is produced by a solar array. If you can immediately consume that by a car at the same time, you have effectively kind of realized real-time usage of renewable energy to charge cars. So we did a project that was supported by the grant accessibility, the CCA renewables grant, and our system's been up and running for 9 months. Here's a look at, this is a single charger on that system. I had mentioned before in a demand, in a load control sense. On this graph, the orange curve is here comes the solar coming in on January 5th. And that unit must have been pretty sunny that day. I think it's a 12 kilowatt installation on the, what's that? 30, okay, the 30 kilowatt installation, but on January 5th, a low incident of the sun, we got a little over 13 kilowatts out of that thing. And here comes a car that's plugged in, an EV that's plugged in. I think the Nissan Leaf in this case. And it's got a, 7 kilowatt, charging capability on it. They can take 7 kilowatts. And here it comes, is we're trying to match, that production with the consumption of that car. So it just ramps up 25%, 50%, 75%, 100%. This unit happens to have been a Clipper Creek unit that you can step change its charging to go in 25% increments. So you got a little 4 blocks. And if you think about, I suppose, expanding that to a larger group, this is what that looks like. So I don't think it's maybe too hard to visualize this, but let's say we got this 12 kilowatts coming from the solar array, and we want to service 3 chargers. And let's make another assumption that 4 kilowatts will do, even though that car can take 7.6, I believe. We're going to distribute that production across a bank of chargers. So not only can you, I suppose, in a holistic sense, distribute the energy is produced by the solar array, but you can, in a more granular sense, task across multiple chargers. I'm going to go back a slide, and this is one of my favorites. This little part over here on the right, this becomes important. Just for a myriad of reasons. But when people show up to chargers, they need to work in some way, shape, or form. So when you're thinking about, when you show up at a gas station, right, that works. The gas works. It goes in the car and you're driving away. If you show up to a charger and it doesn't work, that's bad for a lot of people. Not only that charger, but when you think about the adoption of EVs, you just got to make sure these work. So even though, in this case, over here, we don't have any solar production, but when that when that car charges in after hours, we accommodate that by giving them the minimum that's available, but they're still getting some miles on their vehicle as far as range is concerned. We got a few upcoming projects, right in Henneston, Arrowhead up in the very northwestern part of the state. And we expand again. I think there's just a lot of opportunity, not only in the DCFC space, but in a level 2 space. The applications for these are, we've got to get maybe 4 right out of that, a residential pilot program, the public smart charging as supported by Arrowhead Cooperative, another solar sink in the lake region, and then some workplace smart charging. So I think what's happening is the employees of those companies a lot of times, and or the ratepayers that utilities are speaking and are kind of lobbying those people that serve them with electricity to make chargers available. So what's nice is we're doing, I think, some of the beachhead type work in this, kind of in this group, but certainly your constituents will make you aware, if they haven't already, that they want this. And I think that's a good kind of momentum building for adoption of EVs. Again, DCFC, we're working on some projects there too. And now I'm going to get to kind of our initiative when it comes to, how can we make sure that municipalities, or how can you make sure that you're making really great decisions on how many, where, and what L2s, level 2 charging, and smart charging you want to push out. And we really think a big part of that is allowing data to be shared between municipalities. So this baseline initiative is we're working to push out 100 uncontrolled chargers, i.e. dumb chargers, but just monitoring their usage. So they're smart enough where we can monitor how they're being used, but not smart enough where we're controlling how much power they're giving out in a relative sense to each other. So we're not shedding any of their capability, we're just seeing how they're used. And this is so very important in a competitive landscape of a lot of people trying to get at this market. In a level 2 sense, we saw earlier, there's a lot of vendors available out there, and we want to make sure it's kind of some of our, we call it do-gooder work, that municipalities are making good decisions. So we're working to push out 100 uncontrolled chargers and just sharing the data between all those entities that receive those. We want to share it anonymously, I suppose, and then use that data to define and help you define and refine your EV programs. Quick point on this, I think someone's talking about this a little more.
Yeah, and we're going to be nice if you want to, I think we've talked a lot about this in previous.
Oh, yeah, I'll wrap it up. That's me. I'm a lead project developer for Zep Energy, and thanks for your time.
Awesome, thanks so much. I think just because we're a few minutes behind, we're going to keep moving and then take questions at the end. We want to make sure we get all the presentations in. Next up is my colleague, Brian Ross, here at the Great Plains Institute, and he's going to talk about an awesome project that he's helping coordinate called the Solar Energy Innovation Network. Brian?
Thank you, Diana. I'm going to follow up on Jim's talk because they're actually participating in this project with the Great Plains along with a lot of other people. The Solar Energy Innovation Network is a project that is being run by the National Renewable Energy Lab out of Golden, Colorado. They are funding 9 teams across the nation to figure out how to capture more value from distributed solar generation, the kind of solar investment that gets put onto rooftops and parking lots and behind the meter kind of installations that a city, for instance, might do on a public building or public lands for the benefit of operations. The reason, the genesis of this project was that we're looking from a solar standpoint at a big picture where we're moving from what we call an infant solar portfolio to a grown-up solar portfolio. The graph at the top kind of shows when we're at 1.5% of generation. These are kind of a daily curve here for 14 days in July of what 1.5% of generation by solar means to the load curve for the entire state. And you can see it's just kind of topping off the peak of all those days. If you take go move that percentage up to 10%, all of a sudden the solar generation starts to get to the point where on some days it's actually eating into not only our base load power requirement plants that we typically have to keep running all the time, but it actually gets into where we're exceeding the total load of the state at certain points of the day. And how do we actually address this once we get to kind of this grown-up solar level of deployment in terms of dispatchability and controlling of load? We're similarly looking, when we look forward to the load curve, and Jim talked about this a little bit, for how charging profiles will look. And you can see that this is actually a graph from California, but it's going to be a similar graph from Minnesota once we get to scale of EV deployment, of when the charging will occur and what types of charging will occur. You can kind of see that there's a peak workplace charging peak at around 8 o'clock or 9 o'clock, and then a very big peak in the evening when people get home from work and plug into their homes. And one of the interesting things about this graph is at solar noon, at 12 o'clock there, we're actually dipping down when in fact that's when solar production is at its highest. And so how do we actually match the solar energy curve where we want to take that excess production we're looking at potentially getting from our solar fleet and match it to load for EV charging. And this is where we kind of take the application that Jim was talking about in terms of our small scale project here, and really how do we get to scale at that project and do this on a statewide basis and for very large amounts of power. So the kind of proposal that we put forward was to test and document the performance of a solar plus EV application, kind of a marketing and developing this kind of application to maximize both customer and grid value, the electric utility value, and problems that we might come about if we don't treat them as a single thing. We wanted to create a solar plus EV deployment roadmap. In other words, how to make this technology actually work within the marketplace in a self-sustaining way, so that people are expecting these things to be deployed together. There's infrastructure in place to do that. The market participants are making decisions that will result in a consistent and constant solar and DG solar and EV deployment. And then we hope to design several pilot projects and demonstration projects for distinct use cases and launch at least one new solar plus EV pilot project within the tenure of this project. We have a project team here that includes a lot of different players. The Great Plains Institute, several of the programs that we're working with are all kind of participating in this. Department of Commerce, Department of Administration, and some of their programs. ZEP Energy is participating, as well as Metropolitan Council, and most importantly, Metropolitan Transit is participating in this. Solar Energy Industry and Center for Energy and the Environment. We also have a number of stakeholders that are participating. A number of people who were on this call actually came to our kickoff meeting in early May, some of the cities, to talk about how this might work and what kind of use cases are important to them. We have 5 or 6 utilities that are also participating in this effort, as well as some developers and some other stakeholders in the project. Our overall thesis here is that by combining distributed solar installations with controllable electric vehicle charging infrastructure, we can actually create a value-added product that will accelerate the deployment of both distributed solar and EV deployment, and EV supply infrastructure deployment, and thereby EV deployment. We know that controlled charging of EVs does improve the utilization of the grid, and it limits the risks associated with uncontrolled charging, which Jim talked about, as well as that graph that I showed earlier. That managed energy production on the solar side of distributed solar can help create a predictable and beneficial solar generation profile, rather than just when solar produces, it goes on the grid. We actually manage it in conjunction with a particular use, in this case EVs, so that we create a predictable solar generation profile. And then by deploying those two technologies together, will improve both customer value proposition and grid flexibility. We looked at it, we are looking at part of this project at a number of different use cases. And here's we identified 8 different use cases: workplace charging, public parking or park and ride charging, bus charging, residential homes and residential charging, destination land uses, and this is kind of things like grocery stores and parks that Fran talked about earlier, where people will go as a destination and park by park for some discrete and things like the predictable length of time. Fleets, Mixed use or multifamily applications where you have both commercial and multifamily buildings in the same place and potentially shared parking, and shared utilization of infrastructure as well as a solar load there. And then community solar gardens and how EV control charging with EVs may be able to match with community solar garden subscriptions. The out of those use cases, we kind of thought about what is the public charging value proposition, or the kind of thing that municipalities that are participating in the city's charging ahead program might benefit from out of this hypothesis and out of this these pilot programs we're trying to put together. One is that, of course, combining distributed solar installations with controllable EV charging infrastructure will reduce the installation cost. So if you as a city are looking at doing EV charging, you're also thinking about doing solar, you can combine the actual installation of these, have a single vendor, for instance, the electrician be the same person for both installations, and you're going to get a reduced installation cost for both of those and making both of them more cost effective. Second, solar production is more likely to be used behind the meter where it has the most value. If you have a solar array on your site now, and you are net metering or you're exporting it sometimes back to the grid, you're probably getting less value for that, the revenue from that or the benefit from that than you would if you just consumed it behind the meter. So if you tie the EV production, the EV charging rather, to the solar production, you're going to add value to that solar production by consuming more of it behind the meter. There's also a grid benefit to that by lowering grid congestion of having a lot of solar arrays, putting power back out onto the grid right at solar noon when the load may not be sufficient to achieve that. Third, EV charging will have a lower impact on the electric customer's demand charge. And again, Jim talked about this a little bit, where in Xcel Energy service territory, I think the demand charge is $14 a kW. So if you have 10 EV chargers all running at the same time, you're not talking about a fairly large amount of electric charge, demand charge bump on your electric bill. By coupling these two things, EV charging and solar, you can actually keep that demand charge increase from the electric, from the EV charging at a much lower level, or perhaps, depending on the size of your array, even eliminating it completely. And then finally, of course, there's a positive public perception about using solar for EV charging. Is one of the things that came up very repeatedly in the state's engagement of stakeholders around the VW settlement, is that making sure that EV charging was being tied to renewable energy was a very important thing to people, and something that also adds value to the city. If, and I know a number of the cities that are on the call actually have, for instance, greenhouse gas emission goals or energy goals that they want to achieve as a community, this is a way to help do that in a very public way. So the kind of project outcomes and process, we are working with the national labs as well as local stakeholders to acquire data, model outcomes for the solar plus EV value proposition. I could have presented a whole lot of data that the national labs have already presented around EV charging and kind of what it means, but I only have 15 minutes, so I am just making sure I stay on track. We are convening project participants and stakeholders to guide the roadmap and the pilot project design. We had a meeting on May 8th, as I said, a number of communities that are on this call did participate in that. We will invite anybody who's participating to come to that meeting. We will probably have 2 more of these over the kind of convening the project stakeholders over the tenure of this project, probably over the next year. We are designing alternative pilot projects, and we want to launch these one new pilot. And I'm going to urge cities on the call here to consider being a pilot project. We can work with you on that. There's no direct funding out of our program for pilots, but it is something that is really to your advantage and for future-proofing of your investment to do. And then finally, of course, we will ultimately develop this roadmap to how we take all this information and create a market, a self-sustaining market for this application so that we can reap societal benefits and decarbonization of our transportation system to the maximum extent. Here's the overall process. This is the graphic that kind of shows how it all works. Inventory and data, literature models, engaging stakeholders, designing pilot projects, all of that ultimately going into our solar plus EV roadmap. So our call to action for the cities are that we will ask you on the call to participate in future stakeholder efforts and meetings to the extent that you can, to understand how this is moving forward and what your opportunities are, and to learn about the kind of modeling and pilot designs that we're already moving ahead with over the next year. We want you to think about future-proofing your city's investment in EV charging infrastructure in both your EV and your solar project specifications. If you are installing either one of those, you need to make sure that the specifications you're using when you go out to bid, or the ones that you're using, if you're using an existing bidding bulk buy process that was described earlier, that it includes the design in order to couple your EV and your solar project together. This may be something that you may already have a solar project that you can tie to your EV investment, in which case that's particularly important and a particularly low-cost way to do this. Let us know if you want us to help you design a pilot project for your city. We have some technical assistance to be able to do this. We'd be happy to work with the individual cities on this to make sure that you can move ahead with a pilot project and do this in a way that helps you make better decisions in the future. And finally, we want you to incorporate solar with EV charging in your applications if you're going to make them for the VW settlement grants, which I had to put, this is out of for the VW settlement grant program that will be coming out at some point in the relatively near future. As has already been stated, there is about $1.7 million for electric vehicle charging stations that will be part of that grant. Only 10% of that is for level 2 chargers, which is really what we're talking about. We're not really focusing on DC fast chargers now. So there's about $170,000 for that that's set aside in the program. And one of the things that I wanted to point out that in the plan, one of the core criteria for that the electric vehicle charging station grant portion is that powering charging stations with electricity generated from renewable sources is a core criteria for being awarded the grant. So to the extent that you can tie if you're interested in pursuing this grant, to the extent that you can tie this to a renewable source, it will enhance your options for actually getting an award. And this is something that we hope to engage a few of the cities here on the call again in the near future. Maybe there is even an opportunity to do a joint proposal across several cities to kind of see how we can put together a pilot project where you would do some level 2 chargers that are tied to a solar array, or even other renewable sources in order to enhance your opportunities. So that's my call to action. That's the same program, and hopefully we can get some participation across the programs here.
That would be great. And so there's another resource that Cities Charging Ahead is offering. If you want to explore your charging to include renewables, and I think for a lot of cities that helps meet some of their greenhouse gas goals or energy goals, et cetera. So hopefully we'll have a few cities that are interested. And so if you're interested, just send Diana, me, an email, and we can talk further about that. So the last presentation we had was just about some resources, and that is my colleague Caitlin Bachman, who is co-leading this effort, the Cities Charging Ahead effort with me. And she will share some resources, and with whatever time we have left, we'll take some questions. Okay.
All right, thanks, Diana. So this topic has been touched on a little bit already, but I just wanted to bring it to light again. So we have some utility programs in Minnesota that are eligible for cities to participate in. And really the key point here is that Xcel Energy is currently having conversations right now with stakeholders to improve their electric vehicle plan, and they will be filing something with the Minnesota Public Utilities Commission most likely in September. So we anticipate additional programs to be available and scale up within the next year. Additionally, GRE, Great River Energy, has also been having conversations with stakeholders. So again, we just anticipate more programs to be available for you in the coming year. In the meantime, most of the utility programs right now are residential programs that can be useful for employees that take fleet vehicles home, which might not apply to all cities, but it could apply to some. And then in relation to chargers, there are some rebates for the installation of level 2 chargers. when you're also signed up for EV rates. Generally, a second year is required for this. So I would just encourage you in the meantime to contact your utility and inquire what options, what rates are currently available to you, and then also what's going to be happening in the future, and just stay in touch with them as things develop. So Fran touched on this tool called PlugShare, but I'm going to get into it a little bit more. All right, so everyone should be able to see the PlugShare tool right now. And how this works is there's filters that you can select. So on the slide, I actually have what filters you should click on or off. For most of you, you're probably not going to be looking at Teslas. You can click off all the Tesla-related chargers. Additionally, if you're planning a trip, you're most likely not going to be interested in level 2 chargers. So the CHAdeMO and the CCS plugs in Minnesota are going to be the ones that you're most keenly interested in. And as you can see, we have about 30 chargers, DC fast chargers, that are open for those plugs in Minnesota. We really only have ChargePoint and Greenlots, and then some others, which includes non-networked chargers in Minnesota. So you can leave all of these other ones checked, and it's not really going to make a difference, or you can uncheck them. It's up to you. The other 2 filters I'd recommend including our payment required locations and currently in use locations, and those will be especially helpful when you're planning a trip. They also just released this amenities feature. I haven't explored it too much, but I would encourage you to play around with it. You know, you can check if you want to be located near lodging, dining, Wi-Fi, etc. So there is that available as well. There's a trip planner feature. So you can input your start and ending destinations, and then you can map your route. And then what you can do is determine what your search radius is in terms of looking for DC fast chargers along your route. Or if you want to look at level 2, you can again check that box for level 2. You can input your range for your electric vehicle. So if you have a Nissan Leaf, 100 miles is generally a good range to keep. If you have a Chevy Bolt, you can go, all the way up to 150 miles. You can add wait time. So if you want to be at a DC fast charger for 30 minutes, you can input that information. And then what it'll do, you can map your route. It'll show you all of the chargers available to you along that route. So that's another nice feature, especially if you're helping some people in your fleet plan a trip to take an electric vehicle. So that's pretty much PlugShare. The other thing I wanted to highlight is, again, with the VW settlement, there is an RFP coming out in June. We'll keep you updated as we learn more information. But in the meantime, please do subscribe for updates on the MPCA website. And then again, just a note here that there are EV charging stations on the state contract. And for those of you that are in the Metro cohort, you did hear from Marcus Grubbs at the last cohort meeting. So he's another contact you can reach out to. And we will be sending out these slides after the webinar today so that you can access all of this information following the webinar. So there are some additional tools, and this is my last slide, that I just wanted to highlight, and I won't go into all of them, but you can access some of these links after the webinar. So Fleet Karma is a great website. It has a lot of helpful resources on there for municipalities especially. So feel free to go to links. Fleets for the Future, of course, you heard from Philip earlier, but they have several documents produced on best practices, and there is one on EV procurement best practices. It doesn't necessarily relate to charging infrastructure, but there is some helpful information within that guide. So the other two resources that I wanted to just touch on quickly that I recently learned about is the EVI Pro Lite tool. And this was developed by the National Renewable Energy Lab and California Energy Commission. It helps project consumer demand for EV charging infrastructure. And this is going to be most useful either for statewide or for large cities in Minnesota. So I'll show you what the limitations are here after you select your state. Is that when we're looking in Minnesota, it applies to Duluth, Mankato, Rochester, St. Cloud, Minneapolis, St. Paul. It doesn't have most of the smaller cities that are in City Charging Ahead. So that can be a barrier for using this tool. But you can enter in how many plug-in vehicles you want to support, and it has in here the history information. So let's say we want to scale up to 10,000 vehicles. Then you can calculate, it'll tell you the level 2 workplace charging plugs that are needed to support that number of electric vehicles, as well as public level 2 and public DC fast charging. And it also tells you how many there are currently in the area based on DOE's current information. Now, you can also edit this information. So if you want to adjust the percentage of plug-in hybrids, you can adjust their ranges, all electric vehicles. So this will really help inform how much infrastructure you need based on your area. And then plug-in hybrid electric vehicles, if you don't want to include them in your estimates, you can recalculate for that. You can provide partial support, full support, etc. So that's one tool that's available for your use. And then the only other one I wanted to highlight today was this EV Explorer. And so this is really useful in helping to calculate if you have multiple vehicles, so ones that rely on gasoline or ones that rely on electricity. So I will just put in just to show you how this works. So it'll give you some various vehicles, and you can change all of these in the Car Manager. So for example, if I want to put in what I currently drive, which is Super Forester, it'll tell me how much I'm typically spending on gasoline. And then if I want to say, well, I want to get into an electric vehicle, but these options aren't really in my market, I can tell it, well, I want to look at Chevy Bolt, I want to look at a Nissan Leaf, maybe I'll throw in a plug-in hybrid, just to see how those economies shake out, and it can help influence my decision. Now, this is probably going to be more useful for individuals, but you can also use it to influence your fleet decisions as you're looking at purchasing electric vehicles, and where we'll be driving primarily. And so with that, I know we're a couple minutes over, but I encourage you, if you have any questions, please use the Q&A tool, and we will do our best to answer them.
Thank you, Caitlin. So we'll stick around for a couple more minutes if there are folks that have questions. So we have folks in the room, folks on the phone that can answer them. Any questions? You can type them in Q&A format. No questions? I don't see any. We'll wait another 30 seconds to see if there's a question that pops up.
Kayla and Diana, it might be useful to offer Jim or Brian or Fran the opportunity to respond to Amber's question that I provided some written notes on.
Oh, okay. All right, so the question was, what factors should you consider when right-sizing for chargers? Jim, was there anything else that you wanted to tag on to that answer?
What's the question?
So the question is, what factors should you consider when right-sizing for chargers?
Right sizing, like which charger to use, or, sorry.
Amber, did you have a clarification on that question? So I think what the question is getting at is, when we're right-sizing for chargers, kind of selecting how many you need based on vehicles that you have. So in order to save some money, instead of getting 5 chargers, maybe getting 2 instead.
I'll take a shot at this. I think getting a charger would be like the right first step. I mean, that might be a kind of a cop-out to that question if you're trying to go more of a fleet type approach. But getting a charger and then validating its use, I mean, is a really kind of great start. I am willing to take a better shot at that question as a follow-up as well. That's a good question. And yeah, I'll follow up.
Well, and just some of the, this is Brian, some of the complicating issues here I think that also need to be considered is that right sizing is going to differ whether or not you're using a smart charging system versus a dumb charging system, because when you can actually couple load and manage it in a way with the smart charging system, you can get more charging capability into a single installation than you can if you're just using a dumb charging system. So kind of sizing issues in terms of numbers of charging does change, and part of that dynamic is whether or not you're going to use a smart charging system.
Yeah, I think Philip, you did a nice job kind of answering this contextually. It is a very contextualized kind of answer that will perhaps have some large variances. And I gave maybe an example that popped up in my head as an interesting output was, here's all this solar, for example, that occurs during the middle of the day, but a lot of people charge, you know, at night, perhaps in their homes. So if you want to proliferate that kind of match and that shedding of demand by way of embracing solar, really a push for workplace charging when people don't have their cars in their garages, right? And they're, as a consequence, they're at work. That's a good use. So you really want to make sure to tie, you know, meta right sizing. If you want to be renewable in nature, you need to tie that with the production curve of said renewables. And it's, I think I mentioned this a little bit earlier too, but boy, really think about the customer experience, the EV driver's experience. I think usage picks up when things are just really easy and they work. And the big deal is these people want to get range into their cars, and those that haven't bought an EV charger yet, they need to be pushed into overcoming range anxiety, A, and then just availability of charging infrastructure, B. Those are kind of the two big ones, and you got to have those together. I mean, if you have a car that gets 400 miles, you know, as we get higher battery density in the future here, 400 miles of range, you still just need to have that infrastructure around, to accommodate, the average Americans, 2,000 miles of leisure long distance traveling per year. So if you were to make a big switch out of gas into EV, you gotta have a big network for their over-the-road long distance traveling and or fleet vehicle usage. And you also have to accommodate their kind of residential concerns as well. So that's a pretty big balancing match you're playing there, but I do think you can develop pretty clear paths based upon that use pattern with not a whole lot of calculus involved.
Yeah, to piggyback off of Jim's point about range anxiety and the reliability of charging, I think that's really critical in thinking about the municipal role. You really are trying to create a perception that charging is convenient and easy and it's not going to be a major barrier. And so if you've only done, say, one cable at a single station in a visible place, and you end up having a lot of the time it's used by, say, an employee that works there and it always looks full, people passing by will take note, or people using the various apps to track where they can plug in it will have less of an impact on people's sense of confidence in the range if there's not this balance of an ideal sort of utilization where it's utilized enough to make it worthwhile, but also not so fully utilized that it's not going to provide that opportunity value to other EV drivers who may be looking to stop.
All right, well, I think that's where we're going to wrap it up. Thank you, everyone, for being on the webinar. The next webinar, the third one, will be on September 13th. So we'll be working based on the cohorts and other things that are going on, talking about what the topic and agenda will look like. So thank you so much, and we're signing off.